Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh and good day to everyone. In this video, I would like to continue my discussion in discrete probability where we are going to discuss about subtopic 2.2 mutually exclusively event. Here is the objective for this subtopic where at the end, I want everybody must know how to find the probability of mutually exclusively events. Let's learn about axiom in a probability first. Okay, in a probability, we must know three axioms. The first one, the probability of an event is non-negative real number. That is, probability for A must greater or equal to 0 for any subset A of S. Okay, that means probability cannot be negative. Okay, axiom number 2. Probability S must equal to 1. Okay, that's me. Okay, this is my set S. Okay, and we have an event A here, and the outside of the circle is A prime. Okay, so A, the probability of A must be greater or equal to 0. And probability for F prime also must be greater than 0. Then total for PS is equal to total PA plus probability for A prime must equal to 1. So this is for axiom number 1 and axiom number 2. For axiom number 3, so if A1, A2, A3 until AN is finite or infinite sequence or mutually exclusive events, then probability for A1 union A2 until AN is equal to probability A1 plus probability A2 plus probability A3 until probability AN. So here, what is a mutually exclusive? This is the explanation about mutually exclusive. So from here, you can see there are two Venn diagrams. So this is the first Venn diagram. This is the second Venn diagram. The first Venn diagram, we call it as mutually exclusive. Why mutually exclusive? Because event A, no intersection with event B. Okay, event A and event B, there is no intersection. That's why we call it as a mutually exclusive. While for diagram number 2, Venn diagram number 2, this is not mutually exclusive because event A and event B, there is intersection. Okay, so two events A and B are said to be mutually exclusive if the occurrence of one of the events exclude the possibility of the occurrence of the other events. And if events A and B are mutually exclusive, the probability of the intersection A intersect with B is equal to empty set or null set. Why null set? Because mutually exclusive, no intersection. That's why A intersect B is equal to empty set. So for clear understanding, so let's try example 1. So an experiment has 5 possible outcomes, namely from A1 until A5. Given that these 5 possible outcomes are mutually exclusive, that means there is no intersection, and determine whether the following assignment of probabilities are permissible and give a reason. Okay, for number 1, this is permissible. Why permissible? Because if I total up from probability A1 until probability A5, I will have PA is equal to 1. That's why this is a permissible. Okay, for number 2, this is not permissible. Okay, why not permissible? Because when I total up from A1 until A5, the probability is equal to 1.12. This is not equal to 1. Exam 1 said probability S must equal to 1. Okay. How about number 3? Permissible or not? Okay, so this is permissible. Okay, you can try to total up everything. So you will have PA is equal to 1. Okay, how about number 4? Permissible or not? Okay, number 4, non-permissible. Okay, not permissible. Why not permissible? Okay, because we have a negative probability here. Okay, exam number one said the total the probability cannot equal less than zero. Okay, it must be greater or equal to greater or equal to zero. Okay, and for the last one, okay, this is not permissible. Okay, why not permissible? Because when I total up, I will have PA is equal to 0.98. So this one is not equal to 1. Okay, so I hope you understand for this example. Now, let's see the difference between set theory and also probability theory. If we can see here, okay, the first row, this is about set theory. And the second row is about probability theory. The difference is, for set theory, we just use A. But for probability theory, we have a symbol P here. P, that's mean probability. Same goes to the second picture here. So this is for A prime is a complement of set A, and for probability, PA prime here is a probability of complement of event A. And then the next picture we have for union. Okay, A union B is set A and set B here union. But for probability, we use P here, P A union B. And lastly, this is for intersection. A intersect B is set A intersect set B. While for the last one is a probability P A intersect B. Okay, so how to different between union and also intersection? For union, we always use keyword or. While for intersection, the keyword that always used is and. Now, let's try this example. So, given to us S is equal to 1 until 9, A is equal to 1, 3, 5, 7, B is equal to 6, 7, 8, 9, C is equal to 4, 8, and D is equal to 1, 5, 9. So, let's list the elements of the subsets of S corresponding to the following events. Okay, for the first one, A prime intersect with B. So we already have value for A. So what is A prime? A prime that means other than A. So A is equal to 1, 3, 5, 7. So other than A is equal to 2, 4, 6, 8, and also 9. B, we already have element for B, 6, 7, 8, 9. So the question asks to find A prime intersect with B. Intersect means, okay, we must find an element A prime and B prime are the same element. So the same element between A prime and B prime, we have 6 here, we have 8 and also 9. That means A prime intersect with B is equal to 6, 8, and 9. Okay, so how about B prime union C? Okay, we already have element for B. So what is element for B prime? Other than B is equal to 1, 2, 3, 4, 5. And we already have element for C, 2, 4, 8. Okay, so what is the element for B prime union C? So we compare B prime and C. Okay, if we have two same element, we just count as one. That means we have two at B prime, we have two at C. So we just count one only. So B prime union C is equal to 1, 2, 3, 2, 3, 4, 5, and also 8. Alright, how about A prime intersect with C? So we already have the value for A prime. Okay, from the first one, A prime is equal to 4, 6, 8, and 9. Element C is equal to 2, 4, 8. Okay, so what is the A prime intersect with C? So we just find the same element between these two. So we have 2, 4, and also 8. So the element is 2, 4, and 8. Okay. So now we move to the next one. This is for number 4. A prime intersect B intersect with C. We already have element for A prime intersect B. So this is element A prime intersect B. A prime intersect B is equal to 6, 8, and also 9. And C is equal to 2, 4, 8. So compare. So let's find the intersection. That means A prime intersect B intersect C is equal to, what is the same element here? We can find 8 only. That means the element is 8 only. Alright, how about B prime union C intersect D? So this is the element B prime union C. 1, 2, 3, 4, 5, 8. And D is equal to 1, 5, 9. So the element B prime union C intersect with D. That means the same element between these two, we just have 1. Then we have 5. So 2 elements only. That means 1 and 5. Okay, so and for the last one, I think you can try by yourself. I just give you the final answer. A prime intersect C intersect D is equal to empty set or null set. Please check, is it correct or not? Alright, so how about this example? A market research organization claims that among 500 shoppers interviewed, 308 buy product X, 260 buy product Y, 103 buy both, and 59 buy neither on a regular basis. So, using a Venn diagram and filling in the number of shoppers associated with the various regions, checks whether the result of the study should be questioned or not. So now we are going to draw a Venn diagram. So here, this is our Venn diagram. So and then we have event X and event Y here. So this is for X and this is for Y. Okay, so we have 103 that by both. That means in the middle here, this is for 103. Okay, that by X only is 308. Okay, that means X only is equal to 308 minus 103. So you will have 205. So this is for 205. Then how about by Y only? Okay, buying product Y you have 266. So Y is equal to 266 minus by both 103. So we will have 163. So here 163. And also stated that 59 customer shopper not buying X or Y. That means 59 not buying X, not buying Y. So let's check whether all this value here is equal to 500 or not. Okay, that means 205 plus 103 plus 163 plus 59 is equal to 520. This one is not equal to the 500. So, this example should be questioned or not? Yes, should be questioned. Why? Because the data given to us, the information given to us, is not exactly the answer when we transform it in a Venn diagram. Now, let's discuss about the basic rule of probability. So, there are 3 rules of probability. The first one, we have a subtraction rule. The second one, we have addition rule. And the third one, we have a multiplication rule. Okay, for the first one, subtraction rule. If A and A prime, A complement, are complementary events in a sample space S, then probability A is equal to 1 minus probability A prime or A complement. That means, okay, this is our sample space. So this is event A. And outside the circle is A prime. So as I mentioned earlier, the probability for A and A prime is equal to 1. So to find A, that means 1 minus P prime. Or oppositely, to find PA prime is equal to 1 minus probability A. Okay, the second one, addition rule. If A and B are two events in a sample space S, then probability A union B is equal to probability A plus probability B minus probability A intersect with B. And we have a special case here. Okay, if A and B are two mutually exclusive, that means there is no intersection between A and B. So mutually exclusive in a sample space S, then P probability A union B is equal to PA plus PB only. There is no A intersect B. Why? Because we already know mutually exclusive don't have intersection. That's why PA intersect B is equal to null set. So the formula is A union B is equal to PA plus PB only. And lastly, multiplication rule. If A and B are any two events in a sample space S and PA is not equal to 0, then probability A intersect B is equal to probability B multiply with probability, this is wrong, okay, probability A multiply with probability B given A. Alright, so let's discuss this example. The probabilities that the serviceability of a new X-ray machine will be rated very difficult, average, easy or very easy, respectively 0.12, 0.17, 0.34, 0.29, 0.08. So find the probability that the serviceability of the machine will be rated difficult or very difficult, neither very difficult nor very easy, average difficult or very difficult, and average easy or very easy. Okay, so let this down. Difficult is 0.12. Oh no, this is very difficult, 0.12. Difficult is 0.17. Average is equal to 0.34. And then easy is equal to 0.29 and very easy is equal to 0.08. So the first one, difficult or very difficult, that means probability difficult plus probability very difficult. That means we have 0.12 plus 0.17 is equal to 0.29. Alright, for number 2. Okay, for number 2, neither very difficult nor very easy. That means we are not going to calculate very difficult and very easy. So we are going to find probability for difficult plus probability for average plus probability for easy. So we will have 0.17 plus 0.34 plus 0.29 is equal to 0.8. How about number 3? Number 3, average difficult, very difficult. So probability average plus probability difficult plus probability very difficult. So we will have 0.34 plus 0.17 plus very difficult 0.12. So we will have 0.63. Okay, so I think you can calculate for number 4. So I just give you the final answer. Please try so that you can get the answer. So answer for number 4 is equal to 0.71. How about this example? Okay, so the probability of surviving a certain transplant operation is 0.55. If a patient survives the operation, the probability that his or her body will reject the transplant within a month is 0.2. What is the probability of surviving both of these critical stages? That means do not reject the transplant. Okay, so let's gather all the information and represent it in a tree diagram. Okay. So the first one, okay, whether the patient survive or not survive. Okay, if the patient survive, that means the probability is 0.55. And if not survive, the probability is 0.45. And then given to us also the information. Okay, if survive, the body probability the body will reject is 0.2. Okay, so if survives, okay, if reject is equal to 0.2. If not reject is 0.8. Okay, so what is the probability of surviving both of these critical stages? That means the question asks to find the probability surviving and also what we call surviving and not reject the transplant. Okay, so we are going to find actually P S intersect with R prime. Okay, so this is R prime. Okay, not reject is R prime. Okay, so the formula is probability for S multiply with probability for R given S. Okay, so what is R given S? R given S, that means this one here. Here is R prime given SP. So, what is the probability for S? 0.55. What is the probability R prime given S? So, 0.8. So, the answer is probability S intersect with R prime is equal to 0.44. So I hope everybody can understand my explanation in this video. So all the best and thank you guys. Assalamualaikum warahmatullahi wabarakatuh.